After traveling for 18 months, Voyager 1 will reach Jupiter in March 1979, with Voyager 2 trailing 4 months later.
It's 1979, and two robotic spacecraft are making their way through the outer solar system. Voyager 1 and Voyager 2 are on a mission to photograph the moons of Jupiter, mostly a scientific formality. Scientists expected cratered, geologically dead rocks, frozen, silent, boring. Then the images come back. One of Jupiter's moons, a small pale sphere the size of Earth's moon, is almost completely smooth. Where are the craters? Every other moon in the solar system is pockmarked from billions of years of asteroid impacts. But this one looks fresh. Its surface is covered in long, reddish-brown cracks, like a cracked eggshell, like something underneath it is moving. That moon is Europa, and what might be underneath it would fundamentally change how we think about life in the universe. Europa is roughly 628 million kilometers from the Sun. At that distance, the surface temperature hovers around minus 160 degrees Celsius. By every right, it should be a frozen, inert ball of ice. And it is, on the outside. The surface of Europa is a thick shell of water ice, estimated to be anywhere from 10 to 30 kilometers deep. But beneath that shell, scientists believe, is something extraordinary, a global ocean of liquid salt water, potentially over 100 kilometers deep. To put that in perspective, if you drained all of Earth's oceans into Europa's subsurface sea, you'd only fill it about twice. Europa may hold more liquid water than every ocean on Earth combined. But how can water stay liquid that far from the Sun? The answer is Jupiter. Europa is caught in a gravitational tug-of-war. Jupiter's immense gravity pulls on it constantly. At the same time, the competing gravitational pulls of two neighboring moons, Io and Ganymede, force Europa into a slightly elliptical orbit. This means the distance between Europa and Jupiter changes slightly as it travels around its orbit. And that changing distance means Jupiter's gravitational pull on Europa is always shifting, stretching it, compressing it, over and over in a process called tidal flexing. Think of bending a metal wire back and forth rapidly. The wire heats up. The same thing happens to Europa. The constant flexing and compression of its rocky interior generates enormous amounts of heat. Enough, scientists believe, to keep a vast ocean liquid beneath that frozen crust for billions of years. The same mechanism that makes Io, Europa's neighbor, the most volcanically active body in the solar system, is quietly warming an ocean on Europa. That smooth, cracked surface that confused scientists in 1979. It has a name, linear. Long, reddish-brown streaks that crisscross Europa's icy shell. The leading theory is that these cracks form when Europa's ice shell flexes under tidal stress, splitting open. Warmer, saltier water from below wells up into the gap and refreezes, creating the distinctive reddish bands. The color likely comes from salts, sulfur compounds, and possibly organic molecules mixed into the ice. The surface of Europa is, in a very real sense, the ocean leaking out. There are also strange features called chaos terrain, regions where the surface appears to have completely melted, tumbled around like ice floes, and refrozen in a jumbled mess. These regions suggest that, at some point in the past, or perhaps even today, the ice shell above the ocean was thin enough to break up entirely and churn. On Earth, wherever there is liquid water and an energy source, there is life. We've found microbes in boiling volcanic vents at the bottom of the ocean floor. We've found them in frozen Antarctic lakes, sealed under kilometers of ice. We've found life in acid, in radiation, in the crushing pressure of the deep sea. Europa has liquid water. It almost certainly has chemical energy from hydrothermal vents on its ocean floor, driven by that same tidal heating. And it has had billions of years to develop. If life can exist anywhere other than Earth, Europa is perhaps the single most promising candidate in our solar system. The ocean under Europa's ice is not some distant, exotic environment. In terms of the conditions for life, it may be more similar to Earth's deep ocean floor than the surface of Mars is to anywhere on Earth. For decades, Europa remained a tantalizing mystery, photographed from a distance, but never closely studied. That is about to change. NASA's Europa Clipper spacecraft launched in October 2024 and is currently en route to Jupiter. Arriving in 2030, it will perform nearly 50 close flybys of Europa, using radar to peer beneath the ice, instruments to analyze the composition of the surface, and cameras to map it in unprecedented detail. Its goal is not to land, not yet, but to answer as definitively as possible the question that has haunted planetary scientists for half a century. Is the ocean there? How deep is the ice? Is there chemistry happening beneath the surface that we should know about? If the answers are what scientists hope, a future lander, one capable of drilling through kilometers of ice to reach the ocean below, may one day follow. Europa is 628 million kilometers away, smaller than our moon, easily missed against the backdrop of Jupiter's enormity. But underneath its cracked, frozen exterior, it may be hiding the most important discovery in human history.